All right, good afternoon. Oh, that's loud. It is 3:40, so we'll go ahead and get started since we don't have a tremendous amount of time for the session. My name is John Morello. I'm the CTO at Twistlock. How many of you guys have heard of Twistlock as a company before? Oh, that really warms my heart to see that. This is not a Twistlock presentation, although obviously you have to advertise our logo and pay the bills and so forth. But this is actually a talk on Istio. But it's I think a little bit of a different sort of flavor of a talk about Istio than you might have seen before. My background is very much in security and crypto and just like, kind of old school infrastructure stuff that's no longer in vogue. But what this talk is going to be really about is how Istio provides a lot of capabilities and a lot of opportunities, I guess is the better way to say it, for us to be able to do micro-segmentation and firewalling in a way that's a lot more relevant to the modern applications that you're using and running today, but also actually has some real clear advantages over the old world approach that was a much more perimeterized way to do security that you probably still have and still operate in your environment. So we're going to go through this session in a couple of major phases, I guess. One of them is we'll start off. I'll go through what is a next generation firewall, as the title suggests there. What does Istio really have to do with that, and then really kind of get a little bit more at least into the weeds of how Istio policies work with that and how they can provide you firewall-like capabilities there. If there's any purists in here, anyone that's worked for, I don't know, Cisco or some other kind of like layer 2 sort of company, I fully realize that it is not a true firewall. At the same time, and not a true firewall in the sense of it's not doing the same kind of like capabilities and the full breadth of what you have if you're running a traditional device. However, there's a lot of really relevant things it delivers as a software firewall that those more traditional proper devices, so to speak, historically really have struggled to be able to do, and I think today are almost impossible for them to be able to do for you effectively. And then we're going to look and actually look at what an Istio-enabled environment looks like. We're going to go through a demo at the end, so everybody pray to whatever it is you pray to that the demo works. The internet hasn't been great here, but it's a fairly straightforward demo. I did something a little bit interesting for the demo this time too, in that the Istio project actually has a really great set of docs and sample code and demos. So the demo we're actually going to do is actually the same one that you can run yourself on your own laptop just by cloning the repo and going through the sample stuff. So everything we're going to do here is very easy for you to replicate in your own world as well. So with that, let's go ahead and get started. For those of you guys that may have come from more of the dev part of DevOps or even the ops part that may not have the familiarity with networking concepts, there's been this notion of what's called a Next Gen firewall that's been out for, I don't know, probably quite some time now, maybe at least a decade even. And it's probably the worst way to categorize a piece of technology by calling it Next Gen, because you almost imply there that it's like somehow the end of the generation. Like it's always something is next gen, right? But be that as it may, there is an actual, I guess, term of art, a term that Gartner and other analysts use that refers to NGWF, or NGFW rather, that's specifically about a set of capabilities that basically means instead of the traditional firewall that was, more primitive view that prior to next generation, traditional firewalls were looking probably at mostly layer 2, layer 3, really I guess layer 3 you would say, sorts of capabilities there. To be able to say, for example, like this IP address can talk to this other IP address on this specific port, right? That's the typical model that you've had. Maybe if you go back 15 years ago, that was the predominant sort of firewall rule that you would have in place. Next-gen firewalls added a whole set of capabilities to try to bring the firewall up a little bit closer to the application, providing layer 7 awareness, like the ability to not just say like, I'm going to allow traffic to TCP 22 where SSH is running, but I'm going to also be able to filter that traffic for some common application layer attacks. So not just simply looking at the destination, port, and protocol, but actually looking at the content of the traffic that's passing through that as well. It's similar to what you're familiar with already probably as a WAF, although typically a layer 7 capabilities in a next-gen firewall are broader than just simply HTTP. Layer 7 or next-gen firewalls typically also had some kind of like deperimeterization or reperimeterization technologies. Basically the notion of you being able to put a device somewhere within your data center and to be able to route traffic through that device to zone off segments of that data center from each other to create some kind of least privileged networking model, or I don't want to say segmented model, but at least a segmented model. The notion that's most obvious, of course, is a DMZ, but there's lots of other ways you can take that and do that in a more fine-grained way than just simply having like internet-facing and not internet-facing. Lots of organizations will have something where they'll have a management network and a storage network and web and database and so forth. And those are all the kinds of things that you could do with the typical next generation firewalls. But they were being managed at an IP layer. You were assuming that those entities that you were separating had some kind of relatively static network configuration. They had a certain sort of IP topology. They were almost always going to be running on VMs, I guess, perhaps in bare metal. But all of this, of course, really predates the rise of containers, or at least the containers becoming a mainstream sort of technology. So because of that, you had these devices that assumed that the ways that it was routing traffic were very manual and had a very clear kind of path that they would follow. Like traffic was going to route from this virtual LAN or this network interface to this other network interface on this set of protocols. Again, potentially with some layer 7 awareness that it puts on top of that. Obviously, the applications, though, as we've evolved as an industry, the primary way for authoring applications has really focused around utilizing HTTP as kind of the universal transport, right? It would be sort of weird today in most cases if you were to build some application that relied on some kind of, binary protocol or something that was not HTTP based, right? The whole kind of ecosystem sort of pushes you, for the most part, for a lot of the interactions that you're going to do over the network to be something that's HTTP based. And as that's occurred, especially for connectivity between the client, whatever you're serving out there, and the front end part of your application, as that's occurred, HTTP has basically become the default transport for everything, right? So just to highlight the fact that those traditional firewalls that didn't have layer 7 awareness, if it's simply just saying like, I'm going to allow traffic into 80 and 443, it provides you very little real protection today because all the attacks have also followed the applications and followed the infrastructure to be something that's relevant and done primarily over that HTTP port. I kind of have a joke that I make a lot, but it's really true that HTTP, and I guess maybe more specifically HTTPS, is basically the universal firewall bypass protocol, right? If you think about the way that a lot of organizations, even to this day, have architected their networks, especially if you go to organizations that are not particularly like forward-looking from an IT standpoint. Like, you guys are probably here at Kubecon because you're representing an organization that's trying to, or maybe already has, had a lot more innovation in the way they manage their network. But a lot of those Fortune 1000 sorts of organizations out there haven't made that transition yet. And if you think about the way that they're doing that ingress into their environments, it's in a lot of cases basically just allowing pretty much everything to come in as long as it's coming in over a port that's deemed to be a good port. And that good port is, if it's TLS, it's pretty much anything that you can imagine is going to be flowing through that. So, a lot of people realize that early on. This concept of deperimeterization is not something that was just thought up a few years ago. The earliest that I can remember it being really discussed was around 2003 or so with an initiative that was referred to as the Jericho Forum. But basically the notion there was, instead of you having the perimeter approach, like the perimeter-only approach to security, what a lot of people would call the M&M model, it's hard on the outside and soft in the middle sort of thing, that the idea was instead to bring the perimeter closer to the application. And again, if you think about the state-of-the-art of technology that you had back in 2003 and 2005 and so forth, that state-of-the-art was basically you're going to create some VLANs, and on those VLANs you're going to connect your servers, and those VLANs will then utilize some kind of next-gen firewall as a way to do some interconnect between them, and you'll use that as a mechanism to make sure that things that are going into your DMZ, only have a very specific level of access to your database VLAN or to your storage VLAN or whatever it might be, right? So this concept isn't really something new, and it's kind of spawned out into some other ideas that are related to it, especially the notion of basically being able to take that perimeter and not just dissolve it in terms of the way you protect the applications, but also even the way that you access those applications. For those of you guys that work in probably a more modern company at least, I mean, I think everybody assumes these days at least that you can pretty much work from anywhere, with any device, right? Like, especially if you're a young company or a company that's really embraced a lot of more modern IT practices, you probably can, open your laptop or open any laptop and connect to the majority, if not, the entirety of the applications that you use, through a browser. And it doesn't really matter whether or not you don't have to have like the Cisco AnyConnect client or whatever it is that you've got to have on your laptop to actually create an L2 tunnel between your device and whatever that corporate network is. And so that notion of deperimeterization has kind of, I think, trained people to expect that ability to connect with any of their applications from anywhere, and that just heightens the level of need for us all to be able to support a more software-driven way of connecting applications and separating applications from each other. It's not about just simply end-user access, though. Like we talked about a moment ago, it's about segmenting off the different pieces of your data center. I think most organizations, if you went and spoke to them today and said, it's important that you have some level of separation and zoning of your networks, I don't think you'd really get hardly anybody that would disagree with that conceptually. The depth or the lengths, I guess, that people have gone into to actually implement that can vary quite a bit. There's still a fairly surprising number of customers that we interact with and that you probably are familiar with as well, that their level of segmentation is literally just like there is a DMZ and then there is everything else, right? And if you have that as a layer of segmentation, you really have not really done a very good job of being able to protect your data, your applications, and just be able to control the scope of compromise. One of the concepts that I really believe in, and I think is a very just good security practice, is the assumption that you're always going to have compromises in your environment, and that you should architect your environment and build the controls there to help contain them, to make it more difficult for someone that compromises some application, something that might be lower privileged, from being able to get access to something that's higher privileged. And as those applications that we're all building are transitioning from physical servers, or I guess VMs at least, transitioning from that into something that's really entirely software defined with Kubernetes and containers, those platforms that you use that assume that you're going to have static addresses and VLANs and so forth really are not able to protect you. I mean, it's possible you could architect something and go through a whole lot of effort and a whole lot of pain to be able to create something that could still kind of flow traffic that way. But if you think about the way that Kubernetes, or really most of any of these technologies that are out there, work for interconnecting these microservices, it's really about creating a big flat layer 3 sort of environment, right? And that flat layer 3 environment that you've got out there more or less is opaque to most of the existing tools that you have, right? If you're taking if you have a spam port and you just sort of mirror traffic there, you're just going to be seeing a lot of encrypted, encapsulated traffic. And so you actually have to have the protection within the application, not just simply at the network layer. And we're going to talk about how Istio really makes that something that's feasible to do as code. There's some things about cloud native, and when I say cloud native, I mean I'm not just referring specifically to Istio or to Kubernetes, but just kind of this whole space, what the CNCF definition would apply to. There's some things about cloud native that makes all of this actually a lot harder, frankly. One of the things that makes it harder is what I was just saying, that everything that you're doing from a networking standpoint is basically abstraction on top of abstraction on top of abstraction, right? And Istio just kind of like takes that to another level, so no longer do you actually have like the microservices directly interconnecting. Now you've got an envoy in front of them, and now they're connecting through the service mesh that's on top of that. And so it becomes, I think less feasible, you're less able to be able to configure things in a manual basis and rely on assumptions about what this endpoint is or what its IP address might be or things of that nature. You really are driven. The only way that you can practically achieve this stuff is to actually rely on the tools to have a security topology that actually matches and is continued to match with over time automatically through the orchestrator the underlying networking topology that's being dynamically managed by that orchestrator. So, everything in this environment is ephemeral, everything is constantly changing, and everything is really constantly moving around as well. I mean, you don't really have the notion, although I guess you technically have the capability to, but you don't really have the notion of saying like, I want to run this one particular, application or pod or service or whatnot on this specific node in my cluster, right? I mean, you can do some affinities and things of that nature, but I mean, it's kind of an artificial approach, and you certainly wouldn't want to rely on things like that to control the way that you're doing networking and providing segmentation between the different components of your application. So there's a few things, at least, I should say, about cloud native that makes this actually a harder problem to solve. However, I think it also really, and more importantly, makes it an easier problem to solve as well. As long as you're willing to embrace the tooling and embrace a more modern approach to doing segmentation, you actually have a better tool set and a more autonomous capability to do this, because you're really transitioning what used to be something that was a really kind of device-specific configuration. Your Next Gen firewall, or even your traditional firewall, if you wanted to configure that device, you were going to make an SSH connection or open Cisco ASA Manager or whatever, and you were going to go to that device and you were going to set some configuration in that, and that configuration basically just lived in that device. Whereas now, with this whole notion of basically everything infrastructure related being code, but especially like network policy and configuration being code, the network topology for the application, the way that's segmented, actually lives with the app, right? And you can literally store it in Git, and you can version it, and you can ship it with the application, you can test it, and all the things that make this whole space so attractive for development in general are really equally applicable from a network security standpoint as well. Istio provides that separation of traffic that makes it really possible for you to do a lot of those things, to be able to, to really build, I think, on top of that baseline that you get with Kubernetes and have a more simplistic way of achieving some of those goals. But probably the primary thing that I think that Istio provides, at least makes more feasible for you to do, is the ability to provide true end-to-end network-based crypto. The ability to actually guarantee that you have mutual TLS, that you've got encrypted connections between all the different components of your application without you having to worry about key distribution and key revocation and management and all the other kind of overhead that goes along with operating classical kind of X509 environments. But there's a lot of other stuff that Istio does as well. One of the things that's most important from a segmentation standpoint is the notion of authentication and authorization policies, which is what we're going to actually go through the demo and look at. But those authorization policies effectively allow you to declare as part of the application exactly how the application should work and the different components that are there within it. So let's take a very basic look at the different parts of Istio. If you're looking up on the displays here, you can see that there's really kind of like three main, I guess, aspects to the Istio infrastructure, so to speak, the guts of Istio itself. You've got Pilot, which is the place that's actually managing the configuration and delivering that configuration out there to all of those proxies that are running across the environment. The proxy, which you see there with I guess the pinkish purplish color, that's the Envoy proxy, is what's actually responsible for routing the traffic between the different nodes that you've got within the environment. And then Citadel is the component that actually does all the certificate management for you. If you guys have ever dealt with operating your own certificate authority, and if you've used certificates, or attempted at least to use certificates more broadly than just like sticking them on a web server as a way to provide TLS, you understand the pain that's typically involved with that. Unless you have some kind of certificate revocation and issuance and management layer that's on top of that, it's really tedious and difficult to provision certs out there to everything and then to manage those over time. And Istio really takes a huge amount of that effort out of that for you. So you really don't have to even think about it. It's just a matter of turning on a policy. So if we look at an example of a policy here that you get with Istio, you've got this deployment policy that is a simple YAML file. It makes it very easy to declare how something works. But that simplicity, you shouldn't look at the simplicity as I guess as a detriment or something that's limiting, because the simplicity is actually pretty elegant and allows you to make something that used to be very complex to be able to state relatively easy to say. So imagine that you had an environment where you had a few hundred compute nodes where you're running an application on, and that application you might scale it out to running several hundred pods or something across that environment. If you wanted to have a model where you said like the front-end component of my application should only talk to the cache component, should not directly talk to the database component, if you don't have some kind of layer that can manage that and that you can declare that policy in this simplistic kind of manner here where you can say, front-end can talk to cache, but front-end cannot talk to data tier, It's really hard to do something like that. I would argue it's just, practically really impossible to do something like that. And the aspect of this that Istio really makes much more simplistic is the ability to provide not just the routing of that traffic and the mutual TLS, but that authorization and authentication layer on top of that to provide a strong control about who can talk to what, and to ensure that the what is also controlled by kind of a how, in the sense that you can say not just front end can talk to cache, but you can literally say like specific paths and HTTP methods that it can use. So it's really a layer 7 aware sort of embedded distributed firewall, if you will, in a way that's more powerful, I think, than a lot of those traditional platforms even enabled. So while you're not like looking for a particular threat signatures, for example, like you might think of if you were talking about a kind of a traditional next-gen firewall, the capabilities that you have are actually exceeding what you had in most of those cases, because now you no longer have to worry about routing that traffic. You just simply say everywhere that this application runs, across any cloud, across any infrastructure that it's running on, I always want to make sure that this segmentation, this limited least privileged network approach is applicable, and that I've got a way to authenticate those entities between each other utilizing that TLS, or at least the certificates that are issued for those TLS connections. So the authentication policy is kind of the first step. I usually always describe authentication and authorization almost as a two-step process. You think about authenticating. Authentication is about who you are, right? To be able to say like, I am this identity. And with Istio, that identity is really application specific. And the nice thing, the clean thing about that is you don't have to manage those identities like in some kind of database. It's not a user account. How many times have you dealt with environments in which you had to create some kind of fictitious user to represent a service or an application? You had to cycle the passwords and all the tedium that goes along with that. With Istio, they have this like very clean notion of basically being able to say like this application, just as I build the application, it inherits this identity from the system, and then I can use that identity as a mechanism to then enforce policies about who can talk to what. So authentication is enabled through that mutual TLS, and specifically through those certificates that the Citadel component is automatically issuing to any component that you're running as part of your applications. Once you've got the ability to authenticate, who you are, the next step is, what can you do at that point? So by default, Istio doesn't have authentication, or excuse me, it doesn't have authorization turned on. It's a very simple thing to enable, and we'll do that as part of the demo. But authorization basically is how you're able to say, okay, now that I know who you are, and again, who being the application, I can say what you can do. So authorization is basically being able to say, these are kind of the entitlements, these are the rights, the privileges, however you want to phrase it, that this component of your application has. And again, getting back to that notion that we talked about at the beginning with deperimeterization or reperimeterization, the posture that you want to drive towards is those application components should have the minimal amount of privilege for them to be able to do their job, no more and no less, right? So if an application simply needs to be able to talk to some cache but doesn't need to talk to your user database, for example, no longer do you have to worry about creating a whole bunch of like really brittle and fragile kind of policies about IPs and how's that going to manage as I move my application from one environment to the other and all that kind of stuff, VPCs and such. With this, you can literally just say like this application identity front end can talk to cache, and again, the underlying infrastructure is immaterial to you. So that's really, it's really quite a powerful concept when you think about it, that you can now take that same Istio config and you can run that in Azure, you could run that in GCP, you can run it on premise, you can run it on your own laptop. It really makes no difference at all. No matter where that's running, you're going to have those same identities, that same ability to enforce that least privileged network model. And it's all done in software. So you can, again, version it, you control it in Git, you can make it part of the CI process that you use to manage that, or CI/CD process you use to manage it. There's this notion, there's kind of two notions, and I'm bringing this up now because we'll look at this when we go through the demo. There's two real notions that are important when you define these policies, the notion of a service role and a service role binding. A service role is really defining like that kind of like the scope of authorization. What are you authorized to do as part of this service role? You can talk to this entity, you can talk to this entity using these methods. And then the service role binding says this definition of access, whatever that definition of access may entitle something to, you pair that to an identity, that authenticated identity, in a service role binding that's then used to express kind of the end-to-end flow. So a service role is simply saying like, something that would have this service role is entitled to be able to do these activities. And then the service role binding says that entitlement plus the identity of which has, on which that entitlement has been bestowed, that's the service role binding, and then that's how you're able to actually, that component of the application is able to actually go out and do whatever task that it performs. So it's kind of a two-step process, and it's fairly familiar if you're familiar with services and service roles for Kubernetes and so forth. It's a very similar kind of concept that you have here. So we kind of covered that. I guess I got a bit ahead there, but one thing to point out is that the service role includes that permission section. You'll actually see that in a sample authorization policy here. We're actually going to say, like, what are you able to access? In this case, I can access this product service, and you can see the methods that I can use to access it. So, as we talked about earlier, Istio is not a firewall in the classical sense, where it's, or a layer 3 firewall, at least in the classical sense, where it's talking about IP addresses. There's nothing in this policy that refers to a host name, an IP address. It's simply talking about these primitives that are much more relevant to you as a developer, or at least as an operator, that has nothing to do with the underlying IP topology of the network on which this runs. But we do have the ability to specify some kind of network-ish parameters, at least, by being able to say what are the HTTP methods that it can use. So again, this is a very simple way to have a control point and say the only method, if I have an application, for example, that is serving data but not consuming data, I've got some static website content or something of that nature, I can have a policy that only will allow GETs. It won't allow any data to be pushed back to that service, right? So even though there's connectivity that's allowed there, I can have a policy that restricts, what that kind of connectivity is beyond just allowing the connection to exist. And again, that's something that you could do with traditional firewalls, but they always assumed a certain level of configuration and really of a static configuration of the backend environment. Everything is also completely API enabled, and the reason why that's cool is because it allows products, and of course I'll plug our own product, but allows products to be able to discover that topology and really to help you visualize and conceptualize what that security model looks like. So we'll transition now and actually do a bit of a demo here, but I want to start off with this demo. So what I'm going to be going through when we go through the demo is actually the authorization lab that's on the Istio site. So again, you guys can just clone the repo. You can do exactly the same lab that we're going to do here. And this lab utilizes this bookstore application. So it's a very simplistic app. But one of the things I want to highlight is this application is composed of I don't know, half dozen different services. And they all have their own YAML. They all have their own configuration. And if you're looking simply at the YAML, it's really difficult to figure out what's actually there. But one of the things that, because it's API enabled, that you have the ability to do is to have software that can learn that configuration automatically and give you a much more human understandable way to browse that topology and to ensure that you've got the configuration that you need to have in place. So for example, this, what you're looking at here, is the visual representation of how that application is actually deployed. And you don't have to come in and, and instruct the application, like in this case, Twistlock. You don't have to come in and tell us, like, here's the configuration, or you have to upload YAML and so forth. You literally just have Twistlock go and discover via the Istio control plane, what does that topology look like? And then you can build this map where you can actually see those connections. So in this case, there's actually 4 services that are involved. One service, the product page, is basically the front end for it. And then you have this set of different versions of a review service. You have a rating service, and then you have this book info details. And when you put all that together, you end up with an application that looks like this visually. So you can see here's the details, here's the reviews, the ratings. I think if I refresh the page, you'll see that you get some stars from that. So there's multiple different services that are involved in this topology. And if I look at this application, I can see here, I can see if I click on Istio here, we can actually learn again from the control plane, what are the services that this application has access to, what are the methods that it can use. So you can really understand the entirety of that security configuration in a way that an actual security analyst can do something with. I mean, most guys that are going to be working in a SOC or just on security teams, they're not going to have the level of expertise, or really at least the time to learn, to go through and dig through a bunch of text files and YAML to figure out what the topology looks like. Whereas if you can give them a visual viewer for it, it's a much more easy way for somebody to respond to an incident more effectively and just ensure that the configuration of the environment is straightforward and designed the way that it needs to be. So the bookstore application, again, is composed of these different microservices, and as you can see here when I refresh the app, you can see all the microservices by default are able to connect to each other and talk over Istio. This is just a normal configuration. But what we're going to do now is we're actually going to turn on some of the functionality. So I'll go into Istio here, and we'll just simply turn on and look at the, let's look at the RBAC config to start with. So there's no RBAC config by default. And if we want to go and actually look at what a sample configuration looks like, so it turns it on with inclusion, as you saw in one of the previous slides that we looked at. So we'll just do a kubectl apply. So once we've done that, we can look at the RBAC config again. Actually, let's do a... And then you can see it's got now an RBAC configuration. So once RBAC is turned on, you have to declare, or you have to configure Istio to allow traffic to route between those different components. So right now, not even ingress can talk to that, and so eventually, one of the bad things about this demo is it doesn't take effect immediately, so I'll probably have to refresh it a bit. There we go, finally. You'll get access denied there. So, obviously you don't want your application to be completely cut off from the entire world. So the next step that we'll do in this demo is actually go through and turn on an Istio configuration to enable the ingress controller to see that product's service, right? So let's just look at, again, the YAML for that. As we were looking at earlier, we define the service role that we're going to use. And so you can see the service role here is the product page service. We're going to allow it to be accessed with a GET method. And we're going to apply that to star, which includes the ingress controller. So this basically is going to expose that service to ingress, and this will allow us to load it over the network. So if we come here and we'll apply it. And I need to figure out something to talk to you guys about or say that'll be cool and distract you from the fact that it'll take a little while for this to load. But eventually what will happen here is this page will refresh, and you'll notice that you can see the application, but you're only seeing it partially work, right? And what are we missing here? We're missing details and we're missing reviews. And why are we missing that? Because right now, the only thing that's available is the ingress that you can see here to product page, but product page can't talk to the other backend services right now. And so you can see we're kind of building up from a no privilege model to I guess a least privilege model. Let's take a look at the next step that we'll do, and kind of the last step that we have in the demo here is we're going to enable the product service to now be able to look at the review service, or be able to talk to the review service. So when we go back here, let's take a look at the review service. So you can see here the services and the role that are enabled is details and reviews. Okay, so those components of the page, once this policy is applied, Istio will now allow that traffic to route, and those components of the page will load, and we're going to give that right to be the service role binding. We're going to give that right to the products page. Right? So let's go here and apply that. And if we go back now, notice once we do some refreshes, you'll eventually start seeing everything come up. Right? Takes a little while for it all to propagate. But that's a very simplistic, obviously, example of the different components and how you can go from something where, like, by default, you have no connectivity, and you can layer on those different levels of connectivity. But the thing I really want you guys to take away from that aspect of the talk is the fact that none of those policies that we define there actually had any kind of like traditional network artifact to them. Like, you didn't see any IP address, right? You didn't see any DNS name. It's simply just saying, like, those identities, which Istio automatically manages for you, those identities which you codify access for in a combination of service roles and service role bindings that you can just, again, check in and version in a Git repo, that enables that network topology, that really next-gen firewall notion of deperimeterization and least privilege networking to now follow your application irrespective of the infrastructure that you're running it on. So just to summarize and wrap the session up, microsegmentation is I think it's just generally recognized as a good thing for humanity at all, but it's hard to do with traditional tools, and it's even harder to do if you're trying to apply traditional tools to a cloud-native topology. I would argue it's like functionally impossible for you to use a classical sort of layer 3 approach to provide microsegmentation in an environment like this without going through a whole lot of artificial effort and introducing a lot of fragility to things. Cloud-native applications make it both more difficult, as we were just saying, because things are ephemeral and they're changing, and you don't have some of the primitives that you used to for IP addresses and ports and such. But it also makes it potentially easier. If you leverage these tools like Istio or similar tools that enable you to have a way to declare a next generation firewall policy as code and to version it as code, you really have an opportunity now to be able to do security in a much more scalable way, security that's much closer to your application, security that really takes the protection that you're providing and decouples it from the underlying network infrastructure and now attaches it to the app. So it flows from the developer environment all the way into staging and whatever clouds and whatever environments you run in. And this is all stuff you can use today. I mean, this is capabilities that you have now, certainly something that you can build out and start taking advantage of and really getting the benefits of that deperimeterized security capability that Istio delivers as the next gen firewall that's available. So thanks for coming.